Oh, yes.
Where's Rachel? Where is she? Where's you, Harvey? Where did you put her? Where did Harvey put Rachel? Hello. You're watching Nerdish. I lost my shoe. You gotta put your shoe back on. Very good. What are we doing here? Well, we do SAT, ACT prep for everyone. Yes, and the question is not where is Rachel, but when. 8 to 9:30 p.m. That's when Rachel is. Tuesday, Wednesday, and Thursday. Watch it. Just see what it's like. It's for free. All week long. You can ask us questions like where's Rachel, and what you do with Rachel, and where is Harvey Dent. They're both studying for the SAT. It's a very important test if you want to go to college or university. Nice. I should have said university first because it rhymes. Oh, that's Catwoman. That's okay. I think we know Catwoman because we're Batmen. Let's do a problem. Yeah. We did exponents last time. What should we do? Let's factor a quadratic. Okay. Man, when it comes to education, I'm an addict. Oh my god, but not that kind of addict. No, just a quadratic addict. I hope this is factorable. Oh, it's gonna be factorable. Add 6. Okay. 6 is for Rachel. Alright. Let's take out a 2. Let's make it equal to 0. That's a good idea. Okay. So let's factor out 2. X squared minus 2. How much time do we have before Rachel explodes? Ask Harvey. Harvey. Multiply to positive 3, add to negative 2. I don't think that's possible. Oh, shoot. That's okay. Sometimes you can't factor quadratics. And sometimes you can't save Rachel. I was about to say that. I'm so sorry. No, it's good. It shows that we're tight bonded, like tight bond, original wood glue. It has a tight bond, like me and Levi.
Welcome. It's a big day. Levi, can you work on the...
Yeah, I can.
Yes.
What are you going to do?
I'm just going to hang out for a little bit. Sorry, guys. We need to put our chat up on the monitor, which we forgot to do because somebody, Brady, didn't do it. Brady.
You are, of my business partners, the best.
Thank you. Am I also the worst?
Second.
Second worst?
Yeah.
Got it. Okay. Second worst. So does that mean you're the worst? Do you count yourself as your own business partner?
No, but I'm yours.
True. Yeah, no, I know that.
Forever. Okay.
Today we're doing math.
We're going to do a lot of math.
Let's see. You stay on screen for a sec.
I'll stay on screen for a sec.
Moment of truth.
Mm-hmm.
Come on, baby.
Truth.
Hey!
It
That
didn't
doesn't
work. Great.
And why doesn't it doesn't even give me the chance to move
Elwayne,
around.
what's up? Congratulations.
Elwayne, you're the man of the hour or the woman of the hour. We're not sure, but well done.
Yes.
Well done.
Okay. Also, just people often think that when they get a great score that they're really happy with, they have to stop taking the ACT. You don't. You can keep studying and keep taking the test as many times as you want.
He's absolutely right.
So consider that. Not saying you have to do it, but consider it. Also, check back in over the summer because once Common App stuff comes out, we're going to do a bunch of stuff on college app essays and just discuss those things. So if you want to come back then, I would recommend it. Yes. Also, you can hang out for this stream if you like. Yeah, cool. We will also get you a 35 on your, not that we did it this time, this was, I'm sure, 99.999% you. But we will also help you write the college app or give you tips. The tips will be just write, I got a 35 on the ACT like 60 times.
Absolutely.
Just hit that word count.
Oh, yeah.
Yeah. You know what's not being helpful, Bird?
What?
Either of us.
What do you mean, either of us? Why?
Either of us? Either of us?
Why is this working? Why is this not?
Oh, and do you think you know what questions you got wrong on the math? Since we're doing a bunch of math today. You know it's an underrated movie?
Huh?
Lion King 2.
You know what's a great Lion King 1.5? That was a goofy movie.
Very goofy.
I remember liking that movie a lot.
You're a goofy dude.
It's just kind of my niche word.
It's your niche word?
No, my niche word. Right? Like the movie takes place out in niche word.
Yes.
Yeah.
Yeah.
Levi, why isn't this working?
Because you broke it?
I didn't break it. It's all in there.
Yeah, I was having trouble too.
Were you?
I was.
Oh, that's good.
Yeah. So maybe that helps you.
Yeah, it does.
I don't know if PNGs work.
It did earlier.
Okay.
Yeah.
That's hard to say. Okay, that's fine. Did you pay for the TIR thing to see what questions you got wrong?
Oh. That's why. I never copied it to the computer.
Okay. Honestly, I think maybe the ones I got wrong were what they describe as brute force.
Ah! Well done.
That's cool.
Yeah, it was because I never saved it to the computer.
Oh.
Very
Like
good.
questions over a specific topic, just kind of. Got it. No, I see what you're saying. Yeah, the brute force ones. Do we have any brute forcible ones here?
Like logic problems. Your College Panda book, huh? College Panda.
How would number 10 be for you? How do you feel about number 10, Owen? Is that something that you think might be tough, or is it more logic-y than that?
We're planning on just going through the lot of these things, but if there's, if you like 10, or this is kind of 11, this is kind of fun, or we can just start talking about all of them. So, Wayne, I think they're just looking at it. All right, well, hey, forget that then. Let's go back to number 1.
Well, let's do it.
We have so many questions we can do. All right, see ya, Wayne.
Oh, okay, yeah, see ya. Have a good dinner.
All right, guys and girls, dudes and lady dudes. It's time for the big one.
Mom and Dad.
We've got all sorts of SAT math problems we're going to go through. All right? These aren't just going over exponents and all the exponent rules. We're actually making the rubber hit the road right here. And we're going to be doing a lot of these things to show you how it actually works in the real world. Number 1.
Rubber to the metal.
That's right. If 2x plus 6 is equal to 4x minus 1, what is the value of x? Very simple. Solve this for x, all right? This is basic algebra here. You got to move things around so you get x by itself. So we have 2x plus 6 is equal to 4x minus 1. We have our variable on both sides. We got to get rid of it from both sides, so I'm going to recommend we subtract 2x from both sides and get it off of the left side. We're going to have 6 is equal to 2x minus 1. Just go ahead and add a 1. I think you're going to like it. I'm going to like it. 7 is equal to 2x. Divide everything by 2. And you get x is equal to 7 over 2, which is 3.5. 3.5. All right, that right there. Woo, right there. Look at that. Number 2. What is the next term in the sequence? 4, 9, 6, 11, 8, 13. Let's figure out what's going on in the sequence. All right, I'm going to write these numbers out again just so we have some space. So we have 4, 9, 6, 11, 8, 13. In sequences, normally on the ACT, they're asking about either arithmetic sequences or geometric sequences. That is, either we're adding the same number over and over, or we're multiplying by the same number over and over. But in this situation, it's going up and down and up and down and up and down, so it's not going to be either of those nice sequences. It's part of doing sequences. Let's see if we can figure out the pattern. All right, first thing we do, it looks like we're going to be adding 5. We add 5 to get from 4 to 9. Then we're subtracting 3 to get back to 6. Then we're adding 5. Yep, this is the pattern. Subtracting 3, adding 5, which means the very next term we'd be subtracting 3. So 13 minus 3 is going to give us 10. All right, that's all that is right there. Bam, you can put it on the board. Put it on the board, which is, in this case, the actual board. All right, number 3. A bicycle company makes 5 styles of bikes in 7 different colors. How many different bicycles can the company make when considering both style and color? I like to call this the slot method. You got slots with possibilities. All right, first slot, you got styles. Second slot, oh geez, you can't even see that. This is a disaster. Oh man, sorry. I should have realized that. We got style. Then we have color. Style and color are 2 slots. 5 styles of bikes, 7 colors. You can almost think of this as like the slots in a casino, right? There are 5 different styles. We don't know the names of them, but imagine there's fun and quirky and flirty, and you just kind of, you know, push that spinner and they keep rotating. There's 5 of them. There's 7 in this slot right here, all right? So the way to figure out the total number of options you can have is just multiply those together. 5 times 7 is going to give you 35. 35 options right there. All right. Fantastic. Oh, that was not my best circling, but I will learn. Cool. All right, we're going down. We're going down. All right. So I should probably clean this up because we went down. We went down. All right, we're going to get rid of this. Going to get rid of that. A little bit of that. Okay. All right. Levi, how was your day today?
My day was good. It would be significantly better if people were asking questions about the SAT or ACT.
Really?
Yeah. You think I'd mess around with that? It's not a joke.
Yeah, no, I know. Sometimes you like make jokes about that, though.
I don't.
We got a couple of viewers. That's kind of fun.
Yeah.
All right. I think this is nice and dry.
Hey, there's that thing you don't condone.
Violence. Hey. Hey, we don't condone violence on there.
I know.
Okay?
Ow.
We don't condone
I'm
violence.
not condoning it.
Good.
Nor are you.
We don't condone it. In fact, we do the opposite. We condemn it.
Perpetrate it. Oh.
No, we condemn it. We don't condone violence.
We
don't
condemn violence.
If you think we condone violence, we don't.
No, we are violently against it.
Yes. You want to read number 4 for me?
I want to, yes. Which of the following statements is not true for the function f of x equals 2x minus 3?
Squared.
Squared. Quantity
Very
squared.
good.
Very.
Hey, that's a parabola in vertex form.
You're a parabola in vertex form.
Well, I used
Anybody
to
ever
be.
tell you that?
I used to be before the operation, and now that's no longer my situation.
Right, now you're in standard form.
Yeah. Look at me in standard form. All right, let's go with A. The domain is all real numbers. Well, yes, there's no value of x we couldn't put in here. Keep in mind that the domain is often restricted by when you're dividing by x or dividing by something with x in it. So, for instance, if you have some function like 5 over x minus 2, we can use any value of x as long as we don't use positive 2, because for positive 2 we're dividing by 0, which is not cool. All right, that's one kind of restriction on a domain. Another kind is when you're taking square roots, and you do not want a negative in your square root. So x is allowed to be negative 2 because square root of 0 is 0, that's fine. As soon as x drops below negative 2, we then have a negative number under our square root, and that is unforgivable. So that's what would also restrict a domain. Logarithms would restrict a domain. There's a couple other things that would restrict your domain. But in this case, there's no value of x that we can't plug in. So letter A is true, which means that's not the answer. We're looking for the one that's false. All right, B. The range is all real numbers greater than or equal to 0. Well, we have to think about what this graph looks like, okay? So the vertex form of a parabola looks like this, where the vertex is h, comma, k. So in this case, we have an h value, which is 3. Our k value is 0 because we don't see anything after this, so it's like plus 0. And this is an upward-facing parabola because of this positive 2. That's our a value. That tells us if we're going to be going upward or downward. In this case, we're going upward. So 0 will be the lowest y value we have, which means that B is also true. The graph of the function touches the x-axis when x is equal to -3. If you're touching the x-axis, that's an x-intercept right there. You get x-intercepts when your y is 0. When y is 0, you're on the x-axis. So let's plug in 0 and see if that's true. So we'd have 0 is equal to 2. All right, it's saying that when x is -3. So I'm going to plug that in for x. -3 minus 3 squared. 0 is equal to 2 -6 squared. That's positive 36, which means 0 is equal to 72. Is that true? No, it is not. That is not the x-intercept. So C, I'm going to bet, is the answer here, but let's just go through the rest of them just to be sure. The graph of the function never goes below the x-axis. That is true. Our vertex has a y value of 0, and it's an upward-facing parabola, so it will never go down to the negatives. F of 2 is equal to f of 4. That means that if we plug in 2 for x, we'll get the same output as if we plug in 4 for x. That sounds kind of fun. Let's see if that works. So we have 2 of, we're first going to put 2 in there. 2 minus 3 squared, and apparently that's going to be equal to 2 times 4 minus 3 squared. All right, 2 negative 1 squared is equal to 2. 1 squared, that's positive 2, is equal to 2. Bingo, that's fine. So C is the big problem here. Let us know if you have any questions about that or any questions of your own, because we're also here to crush it and yawn and answer your questions. Very good. All right. Hey, it's pancakes. Levi, you love pancakes.
I do love pancakes.
Good, 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 good.
What about pancakes?
What about pancakes? It's a question about pancakes.
Oh.
Pancakes. The amount of pancake mix required to make pancakes is proportional to the number of pancakes that are being made. The table below shows the required amount of pancake mix and water to make 6 pancakes. How many cups of water are needed to make 15 pancakes? It's a good question. Recipes, batches, ratios, this reeks of proportions to me.
This is a recipe for disaster.
This is a recipe for a proportion. And pancakes, because pancakes are proportions, actually, if you look at it that way.
Did you know that in Alta Ipsum, pancakes means recipe?
No.
Yeah.
That makes sense.
Yeah.
Is Alta Ipsum on Duolingo now? Can I learn it?
Yes.
Good. Okay, because I've been learning Dothraki, and I want to add something onto that.
Is that actually on there?
Yes, it is.
That's cool.
All right. So let's think about this. Is about pancake mix and water. The amount of mix is not really asked about. It's just pancakes and water. So the ratio that we have for one batch, 3/4 of a cup of water to 6 pancakes. Put that right here. So we're going to say, I'm going to call that 0.75. So 0.75 over 6. And when you're doing a proportion, it's really important to keep whatever you have on the top and the bottom consistent. So right here, I'm going to say that this is water and this is pancakes. We're going to set this equal to, they're asking about how many cups of water are needed. So we don't know the water, so that's going to be our variable. But we do know the number of pancakes, which is 15. This is the proportion that we have to solve. So it's going to be 3/4 times 15 times 15 is equal to 6x. Let's divide both sides by 6, divide both sides by 6, and let's see if we can figure this out. 15 over 6, those are both divisible by 3, so I can simplify that. This is going to be 5 over 2. 5 over 2, so 15 over 6 is going to disappear, replaced by 5 over 2. 0.75 times 5, that's 3/4 times 5 halves, really, which is going to be 15 over 8. If you look at the answers, they're all in terms of mixed numbers. Sorry, I kind of wrote over there. So we got to turn 15 over 8 into a mixed number. It's not quite 2, it's 1 7/8, which is E. Very good. Very good, guys. You're doing great. Last one on this page, number 6. Let's give ourselves a little bit of space. Huh? Do you like that, Levi?
I like it.
Yeah, I think you would. I think you would. Maybe I could get rid of this too. I don't know. I don't know. Maybe. All right, while I'm erasing this, in the diagram below, AB, line segment AB, is congruent to line segment BC. Which of the following statements must be true? All right. I'm just going to let that soak in while I clean this. Let the soaking commence. Okay. Maybe if you want to let it marinate, that's also something you can do. Okay, so AB is congruent to BC. What that means, you want to always try to mark your geometric figures with the information that you have. So AB, that line segment, I'm going to put a little line there and a little line there. Means they're both the same length. AB is 1/2 of AC. Let's think about that. So AB is 1/2 of AC. That is true, and here's why. Let's call this segment X, and then because this is the same, let's call that segment X. So, therefore, the entire length of it is 2X, and AB is just X. And X over 2X, it is 1/2 of 2X. So that right there is true. So I'm going to put a little check mark right there. Good. B is the midpoint of AC. B is directly between AC, and on both sides they're equal length, so yes, it is the midpoint of AC. Lastly, 1/2 of AB is equal to BC. So 1/2 of AB would be just like this segment right here. That's 1/2 of AB, and they're saying that that's equal to BC, which is this entire thing. Okay, I don't think so. So that's just going to be 1 and 2, which is going to be... They tried to pull a fast one.
They did.
And I slowed them down. Levi, would you like me to continue, or would you like to do the next page?
I'll take the next problem.
Yeah.
I don't know if I can do it without you though.
Yeah, that's fair. So, yeah, go up. Now go to the right. Good.
Whoa, I set up too fast.
Well, you shouldn't have done that.
I know.
Why did you do that? You shouldn't have done that.
Okay, so
You
we
weren't
have.
thinking.
I'll read it from here. We're gonna do number
Sorry.
7. Yeah, I'll go here.
You can read it there.
Okay, a company has 2 manufacturing plants, Plant A and Plant B. A, B.
Hey!
No, A, B.
Oh.
Bird.
Bird.
Yes.
Yes. Oh, Levi.
I'll leave it. Stop it.
I had a math professor in college that laughed like this.
Really?
Yeah. I
That's horrifying.
I still remember his name. I'm not going to say it, though.
That's very.
He had a goofy name to go with this goofy laugh,
disconcerting.
though. It was actually the first class I had freshman year.
Ooh.
Yeah.
Very exciting. 51.
Yeah.
Nice, nice. I took 42, and then I realized after I finished it, I didn't have to take it. I had placed out of it.
Really?
Yeah. I
Levi.
was very disappointed.
What was 42?
Linear algebra?
No, that's 53.
No, sorry.
Multivariable? No, that's 51.
Calculus. It was calculus.
It's calculus.
Yeah.
Oh, got it. Okay.
Anyway.
Hey, okay, so plant A and plant B.
Plant A, Plant B. 3 times Plant A's production is equal to 1/2 the total produced by the company. Oh, the company has 2 plants. Got it. Okay. Okay, so let's see. If T represents the total produced by the company, which of the following is equal to the amount produced by Plant B? Okay. So, this is a building equations question.
Yes.
Wouldn't you agree?
I would agree.
Yes, and we're going to be translating from English into mathematics because mathematics is the language of logique.
Ooh,
Right.
Fun.
And logic is alta ipsum for Greek.
Yes,
Yes.
very important.
Nobody understands that.
The first math sentence we have is 3 times plant A's production is equal to 1/2 of the total.
So I'm going to go with 3, and then I'll do a lowercase a. So this is Plant A's production. Plant A's production.
What kind of a plant do you think it is? I hope it's like an evergreen tree.
Yeah, I think so.
Maybe it's a rhododendron.
Maybe a Douglas fir.
Maybe sorghum.
Or Coreopsis.
Or a sycamore.
Or a white lily.
Or an oak.
And those are all of the plants.
There are no more.
No more plants.
All right.
3A. So we have 3 times Plant A's production
Is equal to.
is equal to 1/2 the total produced by the company. So this equals 1/2 T, because we said T is the total company production.
Great.
Okay, so this is our equation that we built, literally based on exactly what they told us.
There's one more equation.
And, oh, is there? So I
Yes.
should have done this a better way. But, again, I actually haven't really thought about how I'm going to solve this question.
That's okay.
And it's okay.
It's fine.
And I thought it wasn't going to be until you told me that and put an encouraging hand on my shoulder, followed by an encouraging shoulder squeeze. You want to say something?
No.
Okay.
What's up, guys? Haven't made it to a stream in forever. Taking the ACT with my school tomorrow, hoping for at least a 30. I put one math question in Discord.
Hey, Dalt, what's up?
Dalt, word. We're going to finish this one, and then we'll take a look at that Discord question.
Yes. Okay.
We're excited. It's good to see you back again.
Okay.
Levi.
So we have
T represents the total produced by the company.
Yes, total co-production.
Yes.
Company production.
Which means
yes.
that the total is made from A and B.
Yes, and so that's going to be the second one because we don't know. We have one equation and two variables, and we're being asked to solve for, that's correct. We're being asked to solve for plant B's production, but we don't even have plant B in the first equation, so that's not going to be enough. So now we have two equations and we have three variables.
Doesn't matter.
And it doesn't matter because the answer is in terms of t. So we don't actually have to solve for any variable as a constant. So this is where we really need to be very, very comfortable with equations and systems of equations. When you have a system of equations, you're generally used to getting two equations and two variables. From there, you can solve for both variables as constants. But in this case, if you have one more variable than you do equations, then you're not going to be able to solve that way. But you could solve for one variable in terms of another. That's why you have something like y equals 2x plus 3. This is one equation with two variables. You can't solve for x, and x is not just 5. That's not the answer for x. There are an infinite number of answers for x and for y. They go in pairs. But this is solved for y in terms of x. That's what we're doing here. We're solving for b in terms of what it looks like here to be t. So here's the logical leap that you need to make, is that you have a system of three equations. You want to get it down. You have a system of two equations, and three variables, and you want to get it down to one equation and two variables because that's what these answers are. These are all technically b equals 5/6 t or 2/3 t. So that means we're trying to get rid of a. We don't have a anywhere at the end. So I'm going to solve for a in this equation and work from there.
I would say solve this for B.
¿Por qué?
Solve the bottom one for B. Is you talking about the top or the bottom?
Fine.
Well, because we're going to try to get B by itself anyway.
Yeah, but I'm going to solve
this
for A
one
and
for
then
A.
substitute for A. And then I'll solve for B.
But if you substitute in for A up here, okay, oh yeah, you can do that. Okay.
I agree. So I'm going to subtract B from both sides, and I get t minus B equals A. And this allows me to get rid of A now, because now I'm going to plug in this t minus B. I'm going to put it in for that A.
You want to use the space over here?
No, I'll do it down here. This is fine.
Okay.
So now I am going to put, instead of 3A, I'm going to put 3, can I write it here? I'm spitting a lot. This weird feeling. T minus B, 3 times T minus B equals 1/2 T. And then from there, I wish somebody had suggested a place where I had more room to write.
Over here.
Oh, okay. Oh, that's a good idea. Thank you. Thanks, Wade.
Very good.
So I'm going to just distribute here. I get 3T minus 3B equals 1/2 T. And then we're going to go up here. This is the most ideal way to do this.
You're killing it.
So I'm going to, I'll subtract 1/2 T and add, I'll just rewrite it and do it all again. 3T minus 3B equals 1/2 T. I'm going to subtract 1/2 T from both sides. I get, that's 6/2 T, so I have 5/2T minus 3B equals 0. I'm going to add 3B to both sides. I get 5/2 T equals 3B. I'm going to divide by 3 on both sides, and I'm going to get that this is going to be 5/6 T equals B. So that's going to be our answer because they asked us to solve for B, so the answer is A.
All right, I do. So yes, I do want to challenge you, though, on number of steps here.
Sure.
Because I think there's probably a faster way.
Sure.
So, okay, wait, we got a lot of space here. I'm going to use the space over here.
Sure.
If I were to solve this equation for b,
Mm-hmm.
I would get b is equal to t minus a.
Mm-hmm.
So all I have to do is make sure that our a is put in terms of t. So I go over here and I want to solve for a. I divide by 3 so that a, put it right here, a would be equal to 1/6 t.
Mm-hmm.
And then I just subtract 1/6 t. So that b is equal to 5/6 t.
Yeah, I would say that's pretty much the same number of steps. It's
I don't-
just
really?
Well, you did a lot of work in your head. Like I wrote this line, I got to there, so that's your first line. I haven't done any different work, right? Because we
Yeah.
just subtracted different things.
Sure.
And then I substituted, but I wrote it out, and then I had to distribute. So there's that.
Right.
You found 1/6 t, but you did that in your head, which is also something I would have been fine doing.
All right, so
Okay, so
dividing
you
by
wrote,
3.
you wrote that.
Right.
Then you plugged that in, and then you had to subtract. So I plugged in, I figured that out, and then I just had to, combine my t terms and do it that way.
Yeah, I think just solving this equation is multiple steps.
Sure.
Which it is. There's nothing wrong with that.
Yeah.
I don't know.
Yeah, I mean, it's basically the distribution here is what makes it longer.
Yeah.
Yeah. Either way.
All right, let's look at this Discord problem.
Yeah. If you posted it.
He did. / she did. I'm not sure.
Let's see. Discord.
It's a triangle problem. Law of cosines, law of sines.
I will undo this.
Press spacebar.
That's fine.
You like that?
I do.
Yep.
Okay.
Okay.
Okay, very good. Question types.
All right, Dalton, you ready for us to rock your world?
Do you want me to draw this for you?
Sure.
Dalt, are you still here?
Hope you're still here, Dalton. If you're not here, this would be a disaster.
Enormous disaster. What color do you want to use? You don't have yellow. I'll use yellow for this triangle.
Oh, Dalton's here. Very good, Dalton.
Hi, Dalt. C, V, 18 cm, A, 40 degrees, 12 cm.
Okay, what are they asking for?
You wanna-
Lines are in BC.
So they tell you all this, and then they say, what is BC in centimeters? They give you sine and cosine rule. I can write those up if you'd like.
Okay. Yeah, so Levi's going to write down the law of sines and the law of cosines, which are rules that you can use for non-right triangles to find missing angles and missing sides. If you have a right triangle, you can use SOHCAHTOA to find missing sides and missing angles as long as you know some of the sides and some of the angles, all right? If you know one side and one angle that's opposite it, you can use law of sines, because what law of sines says is you take the sine of an angle and divide it by the side length that's opposite. Whatever that ratio is will be the same ratio as all the other angle sines divided by their respective sides. The problem is we have no complete pair here. A, angle, and BC go together, but they're not a complete pair. 18 doesn't have a complete pair, 12 doesn't have a complete pair, which makes us have to use law of cosines right here. So law of cosines relates the three side lengths of a triangle with the cosine of the angle that is opposite the side that you're trying to find. All right? So we're looking for this. We're going to call this side C, because the side that's C is the side that has the angle that opposite that you know, according to law of cosines. So C squared is equal to, A and B represent the other side lengths, so we'd have 12 squared and 18 squared. 12 squared plus 18 squared minus 2, 12, 18 cosine of 40 degrees. Let me take a look at the answers here to see what how they express it. Okay, yes. So they don't actually solve it for you. They just show you what you would do to solve it. So all you'd have to do in this case is take the square root of both sides. So c would be equal to the square root of all of this stuff, which is going to be e. E is the one that this is equal to. So 12 squared plus 18 squared minus 2, 12, 18, cosine of 40, all of that's underneath the square root. Dalton, does that make sense? You have to understand a little bit about law of sines and law of cosines, which they give you, but if you've never seen it before, it's a little like, huh? What? Huh? Oh, thanks, just need a refresher on trig. Yeah, you got it. They used to call us the trig refreshers before we completely lost our credibility in the war. All right, back to the good stuff.
Dalt, do you have any other questions?
Yes, any other questions, Dalt? Our Discord is ripe for questions. Some would say it's fertile for questions.
Allow me.
Yes. Very good.
Did I really need to draw this up here? Or you didn't. It didn't even seem like you used it much.
Well, no, I mean, they saw laws. No, I was explaining law of sines and law of cosines as you drew them.
Okay.
And I also copied law of cosines with the letters that we had. So absolutely we needed it. I'm finishing another practice test right now. I may have another question in a bit. All right. You said doubt it.
Maybe.
Wait, he's going to get them all right? He or she?
Hopefully.
We'll see. We will see.
Bum, 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 bum.
We will see if Dalton has questions after their practice test. Good. Good, good, good. All right. Number 8. You want to read that one?
Siete.
No.
Oh.
Ocho.
Ocho.
ESPN 8, the Ocho.
ESPN 8. The siete.
Jega.
Okay. There are a total of There are a total of S seats in a movie theater. During a certain week, there were a total of V viewings at the theater with an average of T unsold tickets for each viewing. Which of the following equations represents the total number of tickets that were not sold during that week?
Interestingly enough, they don't give you equations, they give you expressions.
Right.
So this is not the best worded, at least in terms of the question.
I agree. The answer choices aren't
Yes.
very nice, yes.
All right, an average of T unsold tickets per viewing, and which of the following equations represents the total number of tickets that were not sold during that week? All right, well, let's say that there were 10 unsold tickets, and over the course of the week, there were 5 viewings. For every viewing, that's 10 unsold tickets, which would mean you just multiply them together and get 50. So in this case, the number of seats is irrelevant. It's the number of T unsold tickets for each viewing times the number of viewings during that week. And that's all it's going to be, is T times V, which is TV, which makes sense because we're talking about a movie theater, which is losing currently to TV because we're in the golden age of TV, which is why this is the answer. Is that right?
Yep.
Yeah, that makes sense.
My grandpappy told me.
That's, well, there you go. Very good. All right. Number 9. In the figure below, A is parallel to B. What is the value of Z? I'm kidding, I say Z. I don't say Z. Just wanted you to think I said Z for a second. A is parallel to B. So that's this line here is parallel to that line there. And it very much looks like it is. So you can't really assume things until they tell you, but you know, now that we know that, I mean, I could put I'll put the little parallel mark just because it's a good habit to get into. But it's pretty easy to remember these are parallel because they look pretty parallel to me. I'm just going to keep talking about parallelism. All right, what is the value of Z right here? We have parallel lines. I'm not sure how we're going to get there yet, but we do have an angle here, and I'm going to use all the things I know about angles to figure this out. So if 2 angles make a line together, they must add up to 180. So this right here, we're talking about from here to here, that is 180 degrees because it makes a line. So this other thing right here must be 60. because 60 plus 120 gives us 180. All right, other things we know. 60 and 120 give us 180. This also has to be 120 for two reasons. Number one, it makes a linear pair with 60, but also it is a vertical angle from 120. And for the same reason, 60 is going to be what we have down here. Great. All right. So what can I do with that? Well, with parallel lines, whatever angles you get, there'll be corresponding angles below on the other intersection. All right. This line here is just a confusing line. We don't want it. This is not the transversal that we're thinking about. This right here is the transversal that matters. Okay? So we want to take these four angles and put them where they belong down here. So 60. 60 corresponds with x. So I'm going to put 60 right here as well. And then what would be opposite 60 would be its vertical angle, which is z, which is also 60. Just like that, we're done. That's z. Just chasing angles around, trying to put a little lasso around them. Ah, jeez. B. And then once you got them, you drag them back into the barn, and then you corral them, you feed them, you raise them like they're your own, and then when they're old enough, I'm not sure. All right.
Harvest.
It's time to harvest their organs. Good. Organ harvesting. It's that time of year. Harvesting organs.
.com.
For you.
Well, unless you're harvested.
Unless you're the one that's harvested.
You just did 8?
I just did 9, so we're on to 10.
Oh.
You want to do this one?
I do.
Okay.
Do you?
Not necessarily.
Okay. We're going to do number 10. Oh, hello. There we go. For which points on the number line below is the statement x cubed, is that x cubed?
Yeah.
And greater than x squared? Okay.
Yeah.
I'm just going to rewrite that over here. X cubed greater than x squared. So when is this the case? So our first Roman numeral is when x is less than -1. Okay. So that means x is a negative number. And you know what? Let's start with number 3 first, because it's simpler in our head. A positive number greater than 1, that's easy. So we're going to do, okay, if x is greater than 1, would x cubed be greater than x squared? I would say yes, because if x is 1, then you're just going to get 1 is greater than 1. That's not true, but x is not 1. It's greater than 1. So if you have x is 2, then 2 cubed is definitely greater than 2 squared. And anything bigger than 1, as soon as you start multiplying by itself, will just keep getting bigger if we're staying positive. So I like number 3 for sure.
Yeah.
That's the easiest one. With these, I recommend starting on the one that uses the simplest information, if you think that might help. So I like number 3, which means that A is wrong. Wait, let's see.
Yep.
Okay, so A is wrong because it's just number 1. B is wrong because it's just B is wrong because it's just number 2, and then we either have 1 and 3 or 1, 2, and 3, which means I am going to.
Or just
what should
3.
I do? Or sorry, yeah. This makes it look like I crossed that one out. Okay, so it's not A, it's not B. We like 3, so C is okay. Let's look at number 1. So x is less than -1. Can we think of a case where x is less than -1 where this is not true? Because with these types of things, finding counterexamples is lovely. In number 3, I proved that it's always going to, or basically proved that it's always going to be right. But we can also try to disprove something by finding one instance where it's wrong. So, is there a number for x when x is less than -1 where this inequality here is not true? I think we can say that, because if x is less than -1, let's say that x equals -10. Let's go smaller. X is equal to -3. So yes, that's definitely fine because x is less than -1, so we're good there. So if we have x cubed, that's going to be -3 cubed. And is that greater than x? Wait, why x? No. Is that greater than -3 squared? So this -3 cubed is going to be -27.
You're writing over text.
Blast.
You're really close before.
I was really close before.
Yeah.
I heard you hold your breath. Going down here, and then we'll probably go over here and then up there.
Give it the
Like
old,
that.
yeah, absolutely.
The old washer.
Mm.
Yeah? Okay. So this negative 3 cubed is negative 27 is greater than 9. No, that's not true. So 1 is not true. So put a little X there.
I like what's about to happen.
Elwin, hey, what's up? Hey, we have questions for you. I mean, so we can. This is the one that I actually wanted to talk to you about, possibly, because this is sort of logical. Like it's not just solve the inequality. This is we're giving you this inequality for which of these ranges of x values is this inequality true. So we just proved that 3 is good, but we just proved that number 1 is no good. And that's why I started with number 1, because we just disproved 1. That can't be true because I just found a counterexample, which means that any answer choice with 1 in it is wrong, which means that D or E and D are both wrong, which gives us the answer being C. It's just number 3. I don't even have to prove number 2 or disprove number 2 because I got sort of lucky and I was able to find the fastest way to get to the answer choice. I didn't even have to look at all 3. Thoughts on that, Bird?
I really like the ending.
Yeah, Bird likes that type of ending.
Yeah.
With these are very logical things. You're on the ACT. Feel free to graph things. That can sometimes help. But definitely pick out values. That is a way to build up your understanding. You don't always have to think in terms of variables that you can manipulate perfectly and be a really swanky mathematician. Bird is that type of person. Bird is that type of avian creature.
I'm a bird person.
You're a bird person, yes.
Yeah.
But you don't have to. You can put in values, and that way you can build up your intuition surrounding the problem.
Yeah.
So try to disprove things. It's easier than proving things. So I disproved number 1 because I found a value that made that not true, so it's wrong. Simpler.
I mean, if they give you the option that for x is greater than 1, that means that for every possible x that's greater than 1, this should hold. So if you just try one thing, and Levi tried 2, as in Levi tried the number 2 and it worked, then that has to be true. Right?
No.
Why?
Because, so counterexamples, if one thing doesn't work, then it's not true. If one thing does work, it's not definitely true. It's true for that thing. So what I proved in number 3 is that with something pretty small, it's going to work. And then as you get bigger, if you plug in 1,000 for x and 1,000 for both of these x's,
it'll just keep getting bigger.
It's just fine.
Right.
You know, anytime you multiply something by itself, it just is going to get bigger.
If there's an interval, though, where it stops working, that would have to be part of the answer.
Yes.
Right? Like right now we know that 2 works and it's greater than 1. So for some reason, if it suddenly stopped working when you got above a certain number, then you're right, 3 would be wrong. Yeah, you're right. Okay, I see what you're saying. Are you like a math tutor online or something? Something.
We are something like that.
We are something like that.
We are 2 math tutors, but yeah, hello. Hey, sorry we didn't respond right away.
Sorry, Gaming Rick.
Yeah.
Yeah. Yeah, we do this, and we also tutor for not free. You can just kind of message us. There's a link to our website down below for tutoring, if that's what you're looking for. We do certain levels of math. We do ACT, we do SAT, we do a smorgasbord of other things. Okay, L. Wayne.
Let's see if we can figure this one out.
It described a circle with 90 dots around it, and it said if it started at the top and moved in a number of moves every time and colored in a circle, which number would cause all of the circles to be filled in? Okay, we can do a smaller version of this that'll make sense. So let me turn this off.
I did not understand that. So the dots are circles?
Yeah, so there's dots on the circle. So let's say that that's 1, 2, 3, 4, 5, 6, 7, 8. We'll do 8. All right. There are 8 dots on the circle. All right. So what number of jumps, a number of moves every time, would we need to be able to color in all the dots? Well, let's say it was 2. So we start at the top, and let's say we're going to go clockwise. If we do 2, we're going to skip this one and do this one, skip that one and do this one, skip this one and do that one, skip this one and then do that one again. We're going to keep going on the same 4 dots over and over. We're never going to color in the other ones. So that's why 2 would not work. 2 is a factor of 8. Because 2 is a factor of 8, it goes into 8 a whole number of times, which means you're going to keep getting the same dots. The same thing with 4, for example. If you do 4, you start with this, 1, 2, 3, 4. 1, 2, 3, 4. You're going to keep getting 4.
Shoot.
Any even number, you're going to keep getting onto the same dots. So you got to pick a number that's odd and not a factor of 8, like 3. Because if you do 3, yeah, 2 wasn't an answer, but 4 was. 4, however, does not go into 90, which is why, but it's an even number. So it's going to go onto all of the evens, but it's never going to jump to an odd number. That's the problem with 4.
So you'd probably want to find something with 90 dots all around the circle. You're going to want to find a number where as you go by that number, then you end up circling that one that's just before it or just after it or something, so that you're always, and then as you go around again, you're going to be getting that one and that one and that one and that one. And then here, you're now, let's go to squares and squares and squares and squares. That would be, I'm just going to add a dot there. That would be how you want to do it. So you don't want, this is a modulus thing, which is not something that you really need to understand. But yeah, this is definitely a brute force type of thing. With questions like this is just a life thing, or at least definitely a math thing, and a logical reasoning thing. You plug in things, try things, to try to build up an intuition around that thing so that you can generalize to a rule that you can then use without having to think too hard about it.
He's absolutely right.
Yeah,
90
right.
is too many to draw. So maybe you pick 9. I don't know. 9 would be a good way to do it.
My guess is that you could probably eliminate answers. That would probably be the quickest way with this problem. You wouldn't have to check all of the answer choices, but you get rid of 4, get rid of anything that goes into it evenly.
Yes. I'm just saying that if they drew a circle with 9 and then played with it and realized, oh, like if it's 3, that's what they're trying to make us realize. It's like you said, it's a modulus problem.
Modulus.
You gotta inhale that word.
Modulus.
Do you guys ever inhale speak? It's really fun, and everyone likes it. It definitely doesn't get on anyone's nerves, which is
It's
the fun
like
part about
upspeak
it.
and parcel tongue put together.
Modulus. Nerdish. We do it for not free.
It's good. It's also healthy for you. It's healthier to do that than to not do it. So every second that you're not doing it,
Think about how much oxygen you're not inhaling
yeah,
as a result.
it's a problem. It's a
Yeah.
problem. All right.
Speaking of problems, do you have any other... So, Elwin, awesome that you're done with the ACT. Remember, you could do it again if you're into that. Whatever you want. It's also kind of fun. Sometimes.
A little bit.
To study things once it doesn't matter so much anymore, because then it's just fun.
Especially studying with a tutor.
Yeah.
That's also really fun.
Yeah.
We'd highly recommend that.
And paying them.
Yeah, it's really fun to pay them
Yeah.
too.
That's what we found. People love paying tutors.
Yeah.
Yeah, like for this stuff.
Should we go to number 11?
We should go to number 11.
The area of the base of cylinder A is 4 times the area of the base of cylinder B. What is the radius of cylinder A, RA, in terms of the radius of cylinder B, RB? Notice a couple things here. When you think of a cylinder, you should think about, a lot of times they're volume questions. And the volume of a cylinder is pi r squared h, where r is the radius and h is the height. Okay? I'm finally here, glad to not be banned. I really need to find a way to organize my time more efficiently. Oh no. I think I know where this is going. Alright, we'll see, ArcTLT. We'll see. Notice, though, that this question is not about volume. It doesn't talk about volume at all. All they talk about is the bases, the areas of the bases of these cylinders. So really, the fact that they're cylinders is a moot point because the height doesn't matter. Really, this is just a circle problem. So there's circle A and there's circle B because the area of the base is the area of a circle. We don't need to figure out volumes. The fact that the cylinder has a height, not even worth it. So, nice. That's a great little sound you got there. So right here, we're just going to call that circle. Hello there, circle, or circle. And then, okay, this is also going to be circle, and then this is also going to be circle.
I think you need a new marker.
Circle. Nah, dude, this marker's great. All right, so let's reread this with circle. The area of, the base doesn't matter anymore because it's just a circle. The area of circle A is 4 times the area of circle B. What is the radius of circle A in terms of the radius of circle B? Look at that. I'm gonna use my pink marker here. All right, let's turn this into math speak. The area of circle A. So we're gonna say that that's A of A. Area of circle A is equal to 4 times the area of circle B. All right? They want us to figure out what the ratio is, or how radius A relates to radius B. So the radius of a circle, as you should all know, is pi r squared. So area of circle A will be pi. Oh my gosh, that was a pi r. I draw that sometimes. Pi r a squared is equal to 4 times pi rb squared. Okay, good. We got to solve this thing for RA because that's what all these answers are. So let's solve this thing for RA. First off, there's pi's on both sides. We can divide by pi and effectively cancel those out. So we have RA squared is equal to 4 times RB squared. We got to solve this for RA. We just got to take the square root of both sides. Square root of both sides. RA is going to be, now we're lucky here because you can actually take the square root of 4. Turns into 2. The square root of RB squared is just RB. Arby's, we've got the meats. Da-na-na-na-na, da-da-na-na-na.
You're gonna hurt somebody.
Well, that's the theme song to Arby's. Or is it It's Good Mood Food? We got the meats? I think it's one of those. Anyway, our sponsor is Arby's, if you couldn't already tell. RA will be twice RB, which is letrero C. But not yes in Spanish. It's the letter C. Just say, ave say, something like that. I don't know. All right. Levi, you want to do number 12?
Alta ipsum. It means sum it yourself in Greek and Latin and English because you know it now. It's actually in the dictionary. It's in my pocket dictionary. Can you go get that? Well, it is a computer app and
smartphone.
And a smartphone app.
Smartphones.
Smartphones.
Everyone's got them.
Smart Eric. He has it. Does Eric have it?
Eric,
if you don't have Alta ipsum at this point, ridiculous.
What are you doing?
What have you been doing?
What are you doing?
Where are you going?
Seriously, who are you?
To whom do you speak?
Who is your captain?
We need to talk to him.
Or her.
Okay, so, also, this is Alta ipsum. It allows you to track your grades. It allows you to put in when you have things due, and then it'll make a study schedule or a prep schedule or things like that. It'll just do it on its own.
It'll just do it.
And then you can manipulate it as you will, make it your own, make it your friend.
Put Nerdish in there to remember that we stream Tuesdays, Wednesdays, Thursdays, 8 to 9:30 p.m. EST.
Yeah, and then you know how your stress makes you a worse person because you're unhappy and then you mistreat other people, often your parents, and you put them down to make yourself feel better? Well, you can actually do that to Alta ipsum. You can just shove all of your stress into Alta ipsum.
Yep.
What does it do?
It will take all that stress and compress it into a small pellet,
yes,
which it then ejects.
It's like those cubes of garbage in Monsters, Inc.
Yes,
yeah.
Little stress pellets, and do not get them near water because they will expand. Anyway, Alta ipsum is free for the first month.
It is free for the first month.
It is not free for the second month, but it is free for
the
0th month and the first
0th month.
Yes. So you have like an infinite number of free months here.
Yeah, but you missed most
retroactively.
of them.
Yes. So get on that. Alta ipsum.
Get right on top of it. Put your stress into it. Just drop it all in.
And our other sponsor is Original Tide Bond Wood Glue.
Wood. For wood.
Because Levi and I have a tight bond. All right.
Yeah.
That's good.
Next one?
Yep.
Is it my turn?
Oh, wait. Here we go. Okay. Number 12.
Number 12. Ooh, I like doing these in ways you don't like doing them.
What do you mean?
Very good. Okay. We have, hey Eric, we're just going through problems. So if this is what you want to do, great. If it's not what you want to do, not as great. We can talk about other stuff. But let me just do this one. So we're doing number 12. A jar contains blue, red, and green marbles. The ratio of blue to red to green is 3 to 5 to 4. Great. Okay, what is the probability that a marble chosen at random is not red? Okay, so not red means... Not red. We can do a couple of different ways. This is the same thing as saying, so it's not red, so it could be blue or green. It could be either of those. So there are a couple ways to go about this problem. But first, we want probability, right? That you take a marble at random, and you're not getting a red. So what we need to know, we know the numbers of marbles versus each other, or the ratios. We don't know the ratio of any of those marbles to the total, and that's what we need to figure out, okay? So we don't know for a fact that we have 3 blue, 5 red, and 4 green marbles. 7 out of 12. I like the way you're thinking. You're probably right. The way you got 12, I'm assuming, is you added these up and you got 12. So this is not the number of marbles that you have in total. This is just if you were to have 3 red marbles, you would have 12 green. Or 12 total. Oh my goodness, 12 total. So we want not red. So we can do this a couple different ways. We can say, okay, what is the ratio of red to total, and then just do 1 minus that. Or we can just add up the total of blue or green, or blue and green, the total, add them up, and then compare that to 12. Either way, let's just add these two up. So this is blue, this is green. We add them up, we get 7 to 12, so it would be D. There you go. Good job, Eric. Do you have any questions on that? It seems like not. Dalt, I put 3 more questions on Discord. Yes! I got the ellipse one right, but I'd like to hear how you guys do it. Bird, you like ellipses?
I do. I really do.
Yeah?
All right, let's see what we got here.
Oh, what do we got?
We got good stuff.
Yeah?
We got good stuff. Oh, man, look at all of this. This is great. All right. It's great. All right. Here's the first one. So we have 2a over b plus b over 2a. And they're asking, which of these following answers is this equivalent to?
This is. Can you do the ellipse and I do this one?
Yeah, sure.
Please.
Sure.
Okay. Not even looking at the answers, let's think about what we're being tested on in this question.
Circumference.
That's you.
Oh, I probably should be circumference for the ellipse problem.
Yes, then you'd be Sir Major Axis.
Maybe.
I'm Major Axis.
Get out of here. Just do the problem.
Okay. So I don't know the answers, but we have fractions here, and all the answers are just like 2a plus b over b plus 2a. Great, whatever. It's weird stuff like that. We're going from 2 fractions to 1 fraction. Yeah? So how do you get from 2 fractions that are added together to a single fraction that's not added together? It's just a single fraction. You have to add them. How do you add fractions? Common denominator. That's what we're doing here. So the recognition here is I have fractions and I'm adding them. And then you have to go back into your brain from a long time ago, because when did we learn to add fractions? Right. That in bird speaking
Is like 5th grade, maybe?
is 5th grade. I don't know. A long time ago we learned this. So it's just a little more confusing. 1. Great, Eric. Very good. So what is the common denominator that we can get? We have a b and we have a 2a as denominators. Well, we can't find, the lowest common denominator is going to be 2ab. Which means to get this guy to 2ab, we have to multiply by 2a over 2a. And to get this guy to 2ab, we have to multiply by b over b. So what we get is 4a squared over 2ab plus b squared over 2ab. So that will equal 4a squared plus b squared over 2ab. And I don't know if that's an answer. I hope that's an answer. No. Yes. Very good. Ta-da.
Very
Do you
good.
have any follow-up questions? So it's great if you can follow that. That's great, but that's not necessarily what we're trying to teach you every night. We're trying to we're trying to get you to the point where you feel comfortable getting this on your own.
Dalton, here's something else you can do.
We see through that totally. It's clear that you did forget.
Completely.
Yes.
Is that one thing you can do is if you have variables in the question like that and then variables in the answer, you can also put in your own values and just see what happens. So by that, I mean, the first thing they told us in the problem was that a and b are positive. So we can't choose numbers that are not positive, but let's choose some very easy numbers here. Let's say that a is 1. And you want to do b as 1 as well, or is that too much?
Let's try it. Yeah, it'll be easier.
A is 1 and b is 1. So let's see what this would give us. So we're going to have 2 times 1 over 1 plus 1 over 2 times 1, which is 2 plus 1/2, which gives us 2.5. Does The question is, if we put 1 and 1 in for A and B, which of these answers will also give us 2.5? Let's see. 2 plus 1, so that's going to give us 3, over, that's going to be 1 plus 2, which is 3, which is 1. So it's not that one. This is going to be the same thing, which is 3 on top, and this is going to be 2 times 1, which is 2, which is 1.5. So it is not going to be that. This next one will be 4 plus 1, which is 5, over 2 times 1, which is 2, which is 2.5. Interesting. We got 2.5. Let's hold on to that for a sec. This one is going to be 4 times 1 plus 1 over 2. So this is also going to be 5 halves, which is 2.5. Interesting. My marker is not great. And then this one here is going to be, the top will be 5, and the bottom will be 3, which is not right. So we've narrowed it down to one of these two, but the other ones are not going to be right. Here's what you do in this case. Now pick a different number for one of your variables. Maybe B is 2.
Why not 3, my lord?
Well, you can make it 3, but let's just make it 2. I don't know. You put 2 in, one of these is eventually going to get knocked out, okay? That's the strategy for that kind of problem if you don't remember how to make them common denominators.
Yeah.
Yes.
But totally don't forget to add fractions. It's not that you... So is it that you legitimately saw this and you said, I don't know how to add these? Or it just didn't really occur to you because it looked like they were just different things? Because what you did in elementary school and middle school was you added fractions. That's what you did all the time. But now you're in high school and you're not doing that. You're dealing with these different terms that aren't like terms. You can't combine them generally. So then when you see variables, which is what you're used to seeing a lot now, you think, oh, I can't combine them. But they are just fractions. So it's more about recognition than anything else. So as Braid said, it's variables in question, variables in answer, means you can plug in. And as we had on that other one where we were proving number 1, number 2, and number 3, you're trying to prove things wrong. It's way easier. So by plugging in those two numbers, Brady was able to eliminate 3 of the 4 answers. Just because the answer works doesn't mean it's the right answer, because you picked one value of A and one value of B. It needs to be right for all of them.
Correct.
Which is why he didn't really try to prove the right answer, he just disproved all the wrong answers.
Yeah. And then there's one other thing, which is like you're choosing a common denominator. When you're doing it with normal fractions, the best common denominator to pick is the least common multiple of the two numbers. The problem is with variables, we don't know what that is. So you can always create a denominator when you multiply. Just got here. Do you guys read chat?
Yes. Wait.
Like the chat
you?
this?
Yes.
Yes. Yes, we do.
We're reading it right now, and you're listening to us read it.
Do you read the chat?
Yeah.
Because we were actually just talking about that. We didn't know if Buttervader 27.
Are you listening to what we say?
Yeah, that's kind of interesting. Are you watching this too? That's a lot of sensory input.
Are you studying for the SAT or ACT, or do you have parents or children who are?
What I was saying before, we don't condone violence.
Sorry.
We do not condone violence.
Nope.
Is that you can always create a common denominator by just multiplying your two denominators together. So very quickly, for instance, you're going to add 1/2 and 1/4. The least common multiple would be to make these both into fourths. But you can always create a new denominator by just multiplying these together, because you're creating something that is a multiple of both of those. So you can make this into eighths. You got 4/8 plus 2/8, 6/8, which you can then simplify to 3/4, so you're going back to what your denominator probably should have been. However, multiply your denominators together, you're always going to get a denominator that is usable, which Levi is probably about to show you.
Yeah. This is another version. You have x plus 1, you have x minus 1. You have two fractions, you want to put them together. It might look like it's impossible. It's not impossible, it's very possible, okay, Butter? So just listen to me. So in this case, we want to get that common denominator. You do not just add 1 to this one and subtract 1 from this one. That's not what's happening. I'm not studying because I'm only a sophomore, but this stream looked interesting. No. Yes, it does.
Well,
it looks very interesting.
I don't think this stream looks interesting.
No. Okay.
Oh, this stream.
Yes.
Sorry, I thought they were talking about like a different stream that looks like this, but it's not interesting.
Actually?
Maybe.
No, you weren't.
I know.
Okay, yeah, but I mean, if you want to, like, we're just doing math. I don't know how you feel about math. So in this case, we're going to multiply by x minus 1 over x minus 1 on this side. And this side, we're going to do x plus 1 over x plus 1. So the denominator here is just going to be x squared minus 1, because it's a difference of two squares. That's what that is, that's what that is. And then rather than write it separately and then subtract, I'm just going to do this piece minus this piece. So we're going to have 12x and 3x minus that, so we have 9x. Really skipping a lot of steps here. And then negative 12 minus 3, so we have negative 15. And that would be how you combine those. Math is the best. That is absolutely right. Math is the best after English.
Wait. I don't think that.
You do.
Oh.
Do you remember saying that? You said, I think that.
Oh, you're right.
You said, I think that math is best aside from English, which is the best.
Wait, that's what you said.
No, that's what you said. And then you said afterward you would deny it.
That's true. I did say that. Oh, I'm sorry.
You said no one would believe you.
Math is greater than science is greater than reading.
Dalton, do you want to get banned, Dalton?
You don't have the...
I do.
Really?
Do you not?
I don't know. All right, Dalton, here's your next one, which is a super fun one.
Is this the ellipse one?
No, this is vectors.
Ooh, fun.
Yeah.
There is no history. Clearly, Dalton has erased history.
I think he's just talking about ACT stuff.
I don't think so. Well, Dalton is, but I think Butter is not.
Oh. All right.
Reading's your highest score. Nice.
Very good.
That shouldn't happen. Just so you know, this is our personal opinion because we only share opinions. We don't have differing ones.
No.
If your reading score is your English score should be
Correct. And you gotta take into note the frequencies that he just emitted.
Yeah.
Those frequencies contain a lot of data.
Key change.
Yeah, it's a very big key change. All right. So they created a vector system for us. When they say I, they don't mean the square root of -1. This is a new thing. Okay. This is a vector system where if we go to the east at 1 mile per hour, that is represented by the vector I. If we go north at 1 mile per hour, that is represented by the vector J. All right? So Tia bikes 30 degrees west of north at 16 miles per hour. Let's visualize that, because that's a lot of information. 30 degrees west of north means you start with north, and then you go 30 degrees west of that, which is off into the left direction. Okay? So let's just keep in mind our little compass rose. Never eat soggy waffles unless the sogginess is caused by syrup. In which case, just drink the syrup.
Yes.
Which is what Levi literally does. He drinks syrup. He drinks maple syrup.
It tastes good.
I don't know about that.
Yes, you do. You know.
I mean, it's good. But,
Yeah, that's what I said.
I just think about like social conventions and like.
Do you?
Yeah,
you're the type of guy that really adheres strictly to social
Oh,
conventions.
completely, absolutely. Yeah. All right, 30 degrees west of north. So here, we're gonna have our system be this entire thing right here. Okay. So with vectors, you often start with just the center point. We're going 30 degrees west of north. So if this is north, this is east, this is west, and this is south, we are going in that direction. 30 degrees to the west of north. We're going, that way. That's the way that the angle is turning. All right. And this vector, the direction of it is shown right here. The magnitude of it is 16 miles per hour. Every vector has both a direction and a magnitude. And a magnitude basically means the size of it. So 30 degrees west, we've got the direction. 16 miles per hour, I'm going to write that right here. It's a length of 16. The length of it is the magnitude. So the question is, which one of these speeds represents her velocity as well? And what they're doing is they're breaking down her velocity into east and northern movement. So with vectors, a lot of times you have to break it up into vertical and horizontal components. All right. So this component right here is made out of that vector is made out of two components. One of them is a component going to the left, and one of them is a component going up. Okay, which makes a right triangle. All right. So first off, she is definitely going west, and she is definitely going north. So we're going to have some J's, some positive J, but we're not going to the east, we're going to the west. So this needs to be negative I direction, all right? Which means we don't want anything with positive I's in it. So C, D, and E all have us going east because they have positive I, which means that they are all wrong. All right? Yeah, let's get some noise out of these markers. Okay. Both A and B have us going to the left, and then we also need to be going north, which is positive J. Positive J is only found in B, therefore it has to be B.
Northward.
All right? I did not actually have to break down this triangle into its components, but just to show you what that would look like, this is also 30 degrees, which means this is 60. So it's a 30, 60, 90 triangle. The hypotenuse is 16, which means the opposite of that, the 30, is going to be half of that, which is 8. And then the 60-degree side is going to be 8 root 3, which is why we get -8, +8 root 3j. Very good. Very good, Dalton. You put syrup on bacon sometimes. Syrup on anything breakfasty is delicious. It just is.
Specifically, directly on your tongue from the bottle.
If your tongue is breakfast.
What's for breakfast?
Your tongue. Your
Cow
tongue's
tongue.
for breakfast. Are you a cow?
Technically, I mean, every time you eat, your tongue is in your mouth. So maybe it is kind of for breakfast.
I guess. Oh, this is going to be a fun one.
It's mine. You can't do it.
But you just did the one we just did.
No, you just did the one we just did.
Ah, you're right.
Yes.
All right. Are you going to draw this thing out?
I'm gonna draw. No, well, you can draw it if you'd like to draw it.
Sure.
I'm going to just solve the system.
Oh, interesting.
Yeah, it is very interesting.
Oh, because you just the x minus
Yeah.
4s. Okay.
Yeah, it's cool, right?
Yeah.
So you have x minus 4 squared. Dalt, how did you do this one? Plus y minus 3 squared equals 4. So you have that circle, and then you have x minus 4, 4, y minus
Butter Vader asks, "What are we writing on?" Here's a better question, Butter Vader. What are you writing on?
That's a very good question, Bird.
Anyway, yeah, Eric TLT. Hey, the Smith or the Smouth.
Small, what's up?
Smallford is here.
So these are graphed in the same plane. How many points of intersection do these graphs have? So I think you can just graph these on your calculator and
Yes,
then
you
find the
can.
intersection points. So
But-
that's one way to do it.
But you got to go to the conics section of your calculator because you can't just go to y equals and put these in because you need to solve these things for y, which you can do. But when you do that, you're going to end up taking a positive square root. It's only going to give you the top half of the circle. It's annoying. You probably want to go to the conics section, which lets you, today I'll not sleep, which lets you actually put in entire conics equations. Anyway.
Okay. So Brady's going to graph these because these are actually written in a way. This format for each of these is a way that you can really easily draw these things. Here, 4:16 a.m. 4:16 a.m. in the morning. I graphed 3, 4, and knew the radius was 2. Then grabbed 10. Oh, got it. You grabbed the. Okay, got it. I'll sleep at 10:30 p.m. Whoa, what's going on? Ellipse 0, 0. Oh, right. Sorry, different person now. Yes, that's a face. Got it. Okay. So Brady's going to start graphing these. As he does that, I'm going to start solving this system of equations because it doesn't matter what these are going to look like so much, but we know that we have two functions, we have two equations and two variables. We can solve for those variables. Now, it's going to be ugly, but we can solve for them. So this is what I'm going to do. I'm going to do elimination because I have an x minus 4 squared on this side. I can make that go away. Normally, you're used to having, a negative 2x here and then a 2x here, and you have other stuff. You add these two together, great, they go away. In this case, I'm just going to make the whole x minus 4 squared disappear. That seems to be the cleanest way to do this. Now, you could also feasibly FOIL these guys all out, solve for x, plug it in for the other. That would be really painful, but it would work. I'm going to multiply this guy by negative 4. So I'm going to get negative x minus 4 squared minus y minus 10 squared over 4 now, because before we had 16, and the minus is right there, equals negative 4. Then I'm going to add down, and this cancels with this, which is really cool. We get this minus this. Now, those are different things, so they're not going to combine. We have y minus 3 squared, we have y minus 10 squared, so that's not pretty. I'll rewrite it as y minus 3 squared here, minus y minus 10 squared over 4 equals, add those two together, we get 0. That's cool. So then I'm going to have to multiply these out. So foiling these, we get y squared minus 6y plus 9 minus all of this stuff, so that'll be y squared minus 20y plus 100 over 4 equals 0. Please let me know if you're not keeping up with this part. So when we do that, we're going to get y minus, so that'll be 3/4 y. You know what, I'm just going to multiply both sides by 4 because it just doesn't matter. Because if I do that, I'll get a 4 for this part. This will go away. That 4 just doesn't matter because it's a 0 on that side. So we'll get 4y squared minus 24y plus 36 minus y squared minus 20y plus 100 equals 0. 0. 4y squared minus y squared is 3y squared. So those go away. Then we have negative 24, negative 20, so we have minus 48y. So that goes away, and that goes away, plus 36 plus 100 plus 136 equals 0. Then I would simplify these. They're all divisible by, no, they're not all divisible by 3. So then we could just do quadratic formula, or if you could be really smart and figure out other stuff, but I would just do quadratic formula from here.
Discriminate, my lord.
You can't hear us.
Can other people?
I'm confused. Why am I solving for y? So I'm solving for y. Ooh, that's interesting. I'm solving for y because this is a system of equations. Just because it's an ellipse and a circle doesn't matter. They're still functions. They're going to be graphed. The intersection of those things when they're graphed is going to be the same thing as the solution or solutions to the system of equations. I did a bunch of this, and this ends up being slower than graphing because if you understand that stuff, it's much quicker, which is cool.
I will say that if you, yes, exactly what Levi said, these things aren't going to touch.
Yeah, which is cool. So in this case, why not add to both sides and square root? You can. Ooh, that's smart. That's very smart.
Yeah,
that would be smart.
Yeah.
You should do that.
Should we, let's take out the bottom and redo
Yeah,
that.
if we do that, then it'll just go over here. We have, we'll get y minus 3 equals y minus 10 over 4, right?
2.
2, right? And then we'll multiply by 2 on both sides. So we get 2y minus 6 equals y minus 10. So we get y equals, I don't know why this won't work.
-4.
-4. So that's fine.
-4, neither of them even go to y equals -4.
Yeah, so that's going to be an issue.
How did you get to that point?
I think I could have made a mistake, or there could be something with the square roots not working out.
So, okay, wait, x minus 4 squared, you took that and did what with it?
I multiplied this equation by -4, so
Okay.
that this bottom part would go away, and I get a negative of this, so I add them all together.
Y minus that equals -4.
Yeah.
Okay, then you added them together like you did what is it called? Elimination?
Mm-hmm.
Okay, and you get, so positive y minus 3 squared. And you're adding it with negative. Oh, interesting. Giving you 0.
Yeah, it's kind of cool.
Why wouldn't that work? And -4, make it negative, minus that over 4.
This also works. Are you sure you drew that correctly?
So the circle has a center at 4, 3. And it has a radius of 2. So 4, 3, radius of 2. The ellipse has a center at 4, 10. And it's got a x radius of 2 and a y radius of 4. So if you're centered at y equals 10 and you go down 4, it's going to get you down to 6. If you're centered at 3 and you go up 2, that's going to get you to 5. So they're never going to touch.
Yeah, I'm just doing something real quick. Yeah. Oh, nope. I got a positive number, so I must have made a mistake at some point.
Now, wait, this is what they said.
Yeah.
You might have a y value, but you might have an imaginary x value. So
If
if you
you're
take
solving.
-4 in and you plug it in, see what happens.
So you plug in -4, you get -7, so that's 7 squared. Yeah, you bring it to the other side, you have
Yes,
square
that's
root.
why.
Yeah,
That's why.
not
So
good.
there is a y value, but there's not an x value.
44?
Kip,
You're right.
Kip Ascher, you're absolutely right. You're absolutely right. We do have a y-coordinate intersection, but the x-coordinate's non-real. That's why it doesn't intersect. Very good. Very good catch there.
This is a fun problem.
Yes.
Cool.
Yes.
Generally with these, especially when if it's this ugly right away, but it's also clearly written in the vertex form and the, what is this called?
Standard
This
form.
Standard form. It's just quicker to graph them. You see what's going on.
Yeah. You'll know if they're going to cross or not. Yeah, Dalton, stick with graphing.
Yeah, this is honestly, I think this move that I did here is not something they expect you to be able to do. You could feasibly FOIL everything out, solve for one. It would be really painful. Plug it in. That would be painful. You could.
Yeah. I think it's an interesting format that you and I have, though, where like we try a problem 2 different ways, because then kids can see the advantages and disadvantages of both ways.
Right, and that's why they pay so much.
Right.
Yeah.
Right. You guys are just forking it over right now. All right. Any other
more?
problems, put them on Discord. Otherwise, we're going to go back to what we were doing before. What time is it?
It's
Oh, geez, we
9:25
got 5
p.m.
minutes. We got 5. This is a good stream.
Yeah.
We were just busy the whole time.
We were so busy.
So busy. Like bees.
Like
Like busy bees. Buzz, buzz. Don't let...
Condone.
We buzz, buzz.
Ow.
We don't condone violence. We don't condone. We don't condone violence.
I know!
But that's why we don't condone it.
What? I'm confused and hurt.
It hurts, which is why we don't like violence, which is why we don't condone it. So yes, it is painful, but that's why we don't condone it.
I'm going to do a science section. Thanks for all the help. No problem, Dalt.
Thanks
Also,
for the questions.
if you hit some questions that you're unsure about, then you can take some pictures, put them in Discord for tomorrow, if that's what you're into. If that's not what you're into, do it anyway because you have to. Your parents have paid a lot of money for this.
Yeah, a lot of not money.
Oh, bird.
What?
Okay, so we have some time for a couple more questions. Thanks for the follow, Buttervader.
You did number 12 already.
I did.
But we didn't do number 13.
We did not.
Jim, that's my father's name.
Yeah.
Jim is a car salesman. That's not true. He is a pipe product businessman. Okay. Jim is a car salesman who gets a base monthly salary and a commission for each car he sells. Jim's monthly earnings are given by the function f of x is equal to c times 4 plus x, where x represents the number of cars he sold for the month. If Jim sells 6 cars in a month, he earns $2,000. How much is Jim's base salary? All right. Let's think of this. Okay. So f of x is equal to that. X represents the number of cars he sold, and the function over here gives us his monthly earnings. So let's plug that in for x, and let's just sort of see what happens. I don't know what's going to happen. Maybe it's going to be kind of fun. 1 or 2 random question. Okay. So the number of cars he sold is 6. So we're going to say that f of 6 is equal to c times 4 plus 6. All right, and then we know that the f of 6 value, the actual monthly earnings he got was $2,000. So I'm going to put that in for f of 6. So 2,000 is equal to c times 10. And then whatever c is, let's solve for that. We divide by 10 on both sides, and we get c is equal to 200. All right, now c, they don't really ever define it. It might stand for commission, it might not, but it's in the formula, and we just solved for its value. So that's pretty important here. So now, how much is his base salary? His base salary is what he gets if he makes 0 sales. All right? So in order to figure that out, we have to imagine that he made 0 sales and just reevaluate this function. F of 0 cars will be equal to c, which is 200, times 4 plus x, but our x value is 0. So this is be 200 times 4, which is 800. That must be his base salary right there per month. 800. 800. That is a lot of fun. It's a lot of fun. Levi, it's 9:29. What are you thinking?
Okay. Here's what I'm thinking.
Yeah?
I'm thinking we have 1 minute until the end of stream. So, unless there is a burning question that you'd like us to answer this evening, we will answer them tomorrow.
We can also just end this with some acapella. Not by us. We could just like take out a boombox and play some pentatonics. What is that face? Can I ask a quick linear algebra question?
Yes,
Depends how quick it
quickly,
is.
very
It's got to be
quickly.
very
Ooh,
quick. Capacture.
Kip.
Capacture. What kind of music do you guys like? That's not a linear algebra question.
That's
Kip.
Dalton,
No,
that's
I know, but Kip Asher was going to ask it through Dalton.
Oh, that's right. They said that earlier.
Dalton 21. Does A plus B is equal to AB for matrices A and B imply that AB is equal to BA? Kip Asher, we can't answer that.
Maybe? I don't see why that would happen.
We're not. It's been a while. We do ACT and SAT.
Linear algebra is not our forte.
No, it is not. Now, okay, that's interesting. Hold on a second.
Let's see.
So if A plus B is equal to
Yeah.
AB, does that mean that B plus A is equal to BA? No, not necessarily.
I don't see why that would happen.
Right, because it depends on the order that you multiply matrices in.
Let's try to come up with a counterexample because we talked about
But if you can add those matrices together, they must be the same dimensions.
Yeah, so it means that you can, but let's say that these are your two matrices, A and B. I'm going to see if this works. So this will just be 1, 2, 3, 4, right? So AB, if we do A times B, 1, 2, 3, 4.
You're just going to get the zero matrix.
This one? Yeah, so that will work, right?
No, it won't. AB is going to give us the zero matrix.
Yeah, but so will BA. So that's not a good example.
Oh,
So
I thought you said,
use-
so that A plus B does not equal AB in this case.
Yes.
Is that we have to
so how
prove?
would we set that up? I mean, all the zeros, but that would be the same thing. Would that imply that they're That's a hard thing to set up, dude. You gotta figure that out yourself. I'm sure you could look it up. Is that a homework question you got?
Yeah, you doing some kind of a P set, huh? You doing like a little bit of a P set?
You in college? Or, well, no, it's not
Yeah, so
necessarily.
A plus B, the fact that you can add them means they're the same dimensions. And then the fact that you
Yes.
can multiply them means the inner dimensions have to be the same. So if they're the same dimensions, maybe one of them, so matrix A is A times B, and then if they're the same dimensions, B also has to be A times B, but you can multiply them, so these two would have to be the same thing. So maybe these are both C, but if that's the case, then these aren't the same dimensions, so they have to be square matrices.
Yeah.
These are two square matrices.
But then you have to get that. Could they.
They're two square matrices. Multiplication by... I mean, you try to create a counterexample here.
Yeah, it's
So-
kind of hard with counterexample.
Well, what was wrong? I mean, let's not use the zero matrix,
No,
but let's
doesn't
use something else. Let's do like 1, 2, 3, 4, 5, 6, 7, 8.
I'm going to try to do it with a 1 by 1 matrix.
Okay.
But I don't know what times itself is also equal to plus itself. 2? Well, 2, like... For the 1 by 1, it would mean that...
All right, well, here's what we can do. Keep it in terms of letters, which is what they do in linear algebra.
Yeah.
So this is matrix A, matrix B. Right. So if we added them, we'd get A plus W, B plus X, C plus D. Sorry, C plus Y. You want to write the last one?
No, I want
Alright.
to set this equal to the multiplication.
D plus C. And they're
Now
giving
I'm
us...
just multiplying these.
Yeah. They're giving us a rule here. which is that we know that a plus b is equal to ab. So this has to be equal to, and you're multiplying them right now.
Yeah.
Okay, aw plus by, ax plus bz, cw plus bz. Wait, cw
No.
plus dy.
dy for this one.
No. For the left one, cw plus dy.
This is just not supposed to be b.
Yeah. And then cx.
What have I done? I was listening to dy. Okay, so this is dy and this is dz.
cx plus cx.
Cx. Great.
Okay, so now we'd have to set all these things equal to each other.
Yes.
If this was going to be possible. So, oh jeez, this marker. So a plus w would be equal to aw plus by.
You would set up 4 equations with 4 variables. Right?
Yeah, you'd have to, I think. Let's think about this now. A plus w is equal to aw plus by. Right, you're going to have to set up 4 equations, and I'm not sure.
Yeah. I don't want to solve them. So would there be...
Well, we have 8 variables.
Oh yeah, we have 8 variables.
And 4 equations.
So that's not necessarily the way to do it. This is tough. You're right.
Is there... Yeah. I mean, I suppose what you could do is... Okay. You could do...
Can you eliminate things?
A minus AW is equal to BY minus W. You could say that A 1 minus W is equal to BY. So that A, therefore, is BY minus W over 1 minus W. I mean, you could do that with a couple of these, and you get rid of 4 variables. And so you'd have 4 variables left.
Well, I mean, so we didn't finish what they have there. So if we did, so this is
B times A.
This is AB. If we do BA, and then maybe we can recognize some patterns.
Yeah.
Oh boy.
You probably want to rewrite them.
Yeah, I do. I'll just write it here. So W X Y Z. So this is going to be AWCX, AW plus CX, and BW plus DX, and this is going to be AY plus CZ, and that's going to be BY plus DZ. So we know that this equals this equals this.
Interesting.
So how many equations do we have now?
Well, if
Now we have 8 equations. We have a lot more than 8 equations.
we don't know if they're all true though.
Okay,
So
yes. So
AW is the same.
yes, so that's CX equals BY. And here we have... Why is
Is that
that
it?
the only one? No, it would have maybe the... Yeah, DZ, right? Because, yeah, those two.
So therefore BY
BY
is equal to
equals
CX. Oh, but we
which
already
is the
have
same
that.
thing.
Right.
That's
it.
Wait, no, what do we get from here? Nothing helpful. Feasibly, you could solve these, though, now, right? Because you have a ton of equations.
Mm-hmm. But you can't say, we don't know that this is true. All we know is
That's
that A
true.
plus B is equal to AB. We'd have to figure out all the relationships there and then see if that ends up being equal to that.
Yeah.
Yeah.
So that's not teaching us much.
No. Let's call it a night.
Yeah.
Good luck.
Yeah.
They don't pay us enough for this.
Yeah.
All right, you want to press?
Yeah, we'll press
Let's
it.
press the good night button.
Good one to end on, or we can't do it.
Bye, everyone.
Have a good night.
Yay.